Okay, welcome back. More probability. Um, Now we are going to be doing R combinations instead of R permutations. The big difference now is that order does not matter. Okay, so 9.5, counting subsets of a set. Okay, so we call these R combinations, and other notation, the C, N, comma, R, and they also write it like this, N, choose R. So it's problem 1 in the book. List all two combinations for the set ABC. I keep wanting to write a P there. Okay, so one way to think of this is just listing all the subsets. Okay, because sets don't really have an ordering. The set ABC is the same as the set CBA, right? So in permutations, you would, if we're worried about two combinations, or for permutations, we would have like AB, BA, AC, CA. We'd have to do all that. Now we're just going to have AB and no BA, right? What else we have? AC and then BC. Okay, so in this case, 3 choose 2 equals 3. Okay. Okay, what we're after is kind of a formula for this stuff, and we want to relate the R combinations to the R permutations from before. So if we recall, the permutations, if we were called upon to list all two permutations for that same set, in that case it would be the AB, let's write it like AB, BA, AC, CA, BC, CB, right? So there would be 6 of them. In other words, P of 3, pick 2 is 6. And we want to know the relationship between this guy and this guy. Okay, these two guys, what's their relationship, right? Okay, so to find the R permutations, we can kind of do one of these tree diagrams. Okay, so first we would be, and we'll think about the same example we were working with there before. We can first find all the subsets. So one, AB, AC, and then BC. And then for each subset, you list out the number of ways to order those. Okay, and that would give you all the different permutations. So in the first set, the different ways to order that is AB and BA. In the second set, the different ways is AC and CA. And then the third set, BC and CB. Okay. So in other words, in order to find the R permutations, what you're doing is finding the number of combinations. Okay, so you're going to C of N choose R, and then you're multiplying that by the number of ways to order the things in those particular sets. Okay, and that's just going to be R factorial. Okay, and then that would tell you the number of permutations of R objects from N different things. Okay. Okay, and that turns out to be the relationship between those two ideas. Okay, so in general then, we can solve this for a formula for our new function, C of N choose R, by saying, well, hey, C of n choose R must be P of n R all over R factorial, just divided both sides by R factorial on the previous equation. And then I have a formula for P n R, right? So that was n factorial all over n minus R factorial. Okay, and then of course we have this R factorial now as well. Okay, so that's our formula. The other notation, of course, n choose R. Okay, so problem like number 3, they want you to relate P7, 2, and 7 choose 2. Well, that's pretty simple now. P of 7, 2 is equal to just 7 choose 2 times the 2 factorial. Okay, and then we could use our formulas to kind of figure that out if you want to. Okay, the book, the homework may have you try to evaluate some of these again. We've done these before, I believe. So it's just plugging stuff into the formula. So we have 6 factorial all over 0 factorial times 6 minus 0 factorial. The number of ways to arrange 0 things, there's only one way to do that, right? So 6 factorial all over 0 factorial is 1, and 6 minus 0 is 6, so 6 factorial, that's equal to 1. Okay, let's look at some more of the types of problems you're going to be in for. There's 15 students in a student council. And we want to select them. We want to select 6 of them or something like that. Let me read the problem. Okay, so this is number 6 in the book. A student council consists of 15 students. And how many ways can a committee of 6 be selected from the membership of the council? Okay, so in this case, part A, order doesn't matter, right? Having Jim, Bill, and Jen on the committee is the same as having Jen, Bill, and Jim. Okay, that doesn't matter. It's like picking teams. There's not really an order there. So it's one of these new C and R problems, and so we'll set it up as there's 15 students and we're choosing 6 for the committee, and we would figure that out, and that would be our answer. Okay. Part B, 2 members have the same major and are not permitted to serve together on a committee. How many ways can a committee of 6 be selected for the membership of the council? Okay, so there's 3 disjoint sets that will add up. So there's the one, let's say Jim and Bill are the people that can't be on the same committee. So we'll have the one where Jim is on the committee, we'll have the one when Bill is on the committee, and then we'll have the one where neither is on the committee. Maybe I should, yeah. So neither is on. So the first one is when Bill is on the committee, the second one's when Jill's on the committee, and the third one when neither, or something like that. Okay. Okay. So in the first case, we already know that one of the kids is on the committee, right? So how many students are there to pick from? You may want to say there's 14, but not really, right? Because there's 2 people we're not choosing from. So there's actually only 13 people to choose from. And from those 13, because we already have one person on the committee, we're just choosing 5 of them. Okay, and that's the same case for over here. So let's say, I don't know, forgetting like which one was on the committee and which wasn't. So we'll say maybe this guy's on, this guy's on, and we can't do it like that, and then those are off. So let's say Jay is on and Bill is not on. So I put an X there if they're not on the committee. This one Jay is not on. This one Jay and Bill, neither one's on. Okay. Okay. So in the second case, then Jay's not on, but Bill is, right? So there's 13 people left to pick from, and we're picking 5 of those. We're choosing 5 of those. Okay. In the third case, then neither one of those people are going to be chosen. So there's 13 left over, and from those guys we're choosing all 6 of them. Okay, let's look at part C. 2 council members insist on serving on the committee together. If they can't serve together, they won't serve at all. Okay, so in this case, either they're both on or they're both off, right? So we'll say Jay and Bill are both on, or Jay and Bill are both off. In the first case, there's 13 people left over to choose from, and we're only choosing now 4 of them because we have 2 that are on or supposed to be on the team. In the second case, there's 13 people to choose from, and we're getting 6 of them now because neither Jay or Bill are going to be on the team. Okay. Part D, suppose the council contains 8 men and 7 women. Okay. How many committees of 6 contain 3 men and 3 women? Okay, so you could think of it as kind of an order of you're doing stuff, tasks in order. So first choose the men. Okay, so out of 8 men, you want three of them, and then choose the women. So we're multiplying these together. So out of 7 women, we're going to choose 3 men and 3 women. So we need 3 women. Okay. Part 2, how many committees of 6 contain at least 1 woman? So that would just be the number of committees that don't contain any women, which would be 8 choose 6. So you're picking all men. It would be the total number of committees in general, right? So that would be depending on how many we had, was it 15? Yeah, 15 choose 6. And then you subtract away the number that don't have any men, right? Or sorry, the number that don't have any women. So again, what are they asking? How many committees of 6 contain at least 1 woman? So it's basically the total number of committees minus the committees that have no women. Okay, and the ones that have no women, that's where we took the 8 men and chose all 6 from that category. Okay. Oh, what else? Part E, suppose a council consists of 3 freshmen, 4 sophomores, 3 juniors, 5 seniors. How many committees of 8 contain 2 representatives from each class? Okay, again, you want to think of it in terms of, I guess, multiplying these particular numbers together. So first, we want 2 of each, right? So we want 2 of the freshmen, and there are 3, I think there are 3 freshmen. So 3 freshmen, we choose 2 of those. And then we want 2 of the sophomores, there's 4 of those, we choose 2 of those. And then there's 3 juniors, we want 2 of those. And then 5 seniors, and we choose 2 of those. And then you just multiply those numbers together, and you'll have your answer. Okay, so there's a lot of those in the homework. They talk about poker hands in the book, which is really interesting, but it's not in the homework, and I'm not going to beat you up over it. The next section that's relevant to us would be permutations with repeated elements. Okay. So I'm not sure what number I'm on. I think I'm on 3. Permutations with repeats. Okay, and let's look at number 19. So we're trying to figure out how many different ways can we rewrite the word hula balu. Okay, and you could do it as a series of tasks and multiply at the end, right? So first you want to pick the 3 slots for the L. Right, so you have 1, 2, 3, 4. How many other? 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're picking 3 of those for your L's, and then you want to pick 2 for the A's, etc. Right? And then we're picking 2 for the O's, and 1 for the B, and then 1 for the H, and then 1 for the U. Okay, so what is that? Because they're all the same, you're using your choose notation. So the first one is 10, choose 3 of them, and then 7, choose 2, and then 5, choose 2, and then 3, choose 1, and then 2 slots left, choose 1, and then there's just 1 slot for the final remaining guy. Okay. We can rewrite this, and you're going to see a huge cancellation in the product, right? So it'd be 10 factorial all over 3 factorial times 10 minus 3, which is 7 factorial. And then times 7 factorial all over 2 factorial times 7 minus 2, which is 5 factorial. Times 5 factorial all over 2 factorial times 5 minus 2, which is 3 factorial. Times 3 factorial all over 1 factorial times 3 minus 1, which is 2 factorial. Times 2 factorial all over 1 factorial times 2 minus 1, which is 1 factorial. And then 1 factorial all over 1 factorial times 1 minus 1, which is 0 factorial. Okay. And then here is the kind of the punchline. There's this huge, nice cancellation of terms, and we end up with 10 factorial, which is the total number of letters, divided by a factorial product, or factorial factor rather, for each of the repeated letters, right? The number of repeats. And then of course 0 factorial is just 1, so we don't need to include that. But that turns out to be the general formula for when you're doing these. For example number 20, we want to know the number of ways to write millimicron. Okay, so you count up the number of letters. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 factorial. And then you start dividing out by repeats, right? So there's 1, 2 m's, so 2 factorial. There's 1, 2, 3 i's, so 3 factorial. There are 1, 2 l's, so I need a 2 factorial for that. And then there's 1 C, 1 R, 1 O, 1 N. So you just need a bunch of 1 factorials, but 1 factorial is equal to 1, so why bother, right? Okay, there's lots of other good stuff in there. I think we're just going to repeat, kind of skip that because it's not in the homework. No sense in getting carried away. You should be able to get through the homework at this point. Let me sort of scroll over and see if there's anything kind of worth going in and dealing with. Some big numbers you have to deal with. Okay, I guess number 7. How many 15-bit strings contain exactly 7 ones? So what you're doing there is kind of just ordering. It's kind of like the problem we just did. You know, you have 15 things, and then 7, of them are ones, and then 8 of them are zeros. So you can kind of pull it off like that, and that's the same as 15 choose 7. So you can figure that out. Same kind of idea. How many 15-bit strings contain at least 12 ones? Well, you use disjoint sets here. So there's the ones that contain 12 ones. So that would be 15, choose 12. And then the ones that contain 13 ones, 15, choose 2, all the way up to the ones that contain 15 ones. 15, choose 15, which is just one. There's only one. Contain at least. How many 15-bit strings contain at least one? Well, that's just the total number of 15-bit strings, which is 2 to the 15, minus the ones that don't contain any ones, right? And there's only one of those. That's the one that's just zeros. So that would just be 2 to the 15 minus 1. Okay. How many 15-bit strings contain at most one? At most one. Well, there's only one string that contains no ones, and that's well, okay. So there's 1, 2, 3, 4, 5, 6, 7. Yeah. How many 15-bit strings contain at most one? So there's the one that contains no ones, and then there's the one that has a 1 in this position, and then the one that has a 1 in this position, and then the one that has a 1 in this position, and zeros everywhere. The one that has a 1 in this position. So there's 1 plus the 15. You know, the first one's 1, 0, 0, 0, 0. The second one is 0, 1, 0, 0, 0, 0, 0. The third one is 0, 0, 1, 0, 0. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 40, 15 of those, right? So it's 15 plus 1 or 16 of them. These problems. Suppose there's 5 microchips in a production of 30 that are defective. A sample of 7 has to be selected and checked for defects. How many different samples can be chosen? Order here does not matter, so there's 30 possible, and I think it said we're checking 7 of them or something. A sample of 7 has to be checked, so 30, choose 7 possible sort of orderings of samples. How many samples will contain at least one defective chip? So that would be the total number of chips minus the ones that don't have any defective ones. Okay, so the total number of defective chips, 30, choose 7, minus, so how many of them are good? There's 5 bad ones, so there's 25 good ones, and that would be this would be the number of selections that have all good chips. Okay, this is the total number of selection of chips. This is the run where all 7 of them are good. What's the probability that a randomly chosen sample of 7 has at least one defective? That's just 30, choose 7, minus 25, choose 7, all over 30, choose 7. Oops, we don't need that symbol in there. 10 points. So for this one, when you play around with it, it says 10 points labeled A, B, C, D, E, F, G, H, I, J are arranged in a plane in a way that no 3 lines are on the same straight line. How many straight lines are determined by the 10 points? In order to pull this off, you kind of want to put all your points in a circle to play around with it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9.